Hey guys, welcome back once again. Today we're going to be talking about y equals mx plus b. This isn't a new concept for us. I have mentioned it a couple times, so we're just going to really solidify the idea today. Our learning target, again, we're comparing rates of change in initial values and interpreting them in context. So same learning target as yesterday, but let's see, what are we going to be able to do at the end of the day today? First, we're going to be able to identify the y-intercept from an equation. We did briefly mention this in the last lesson, but we didn't hone in on it and talk about it to a great extent. We're also going to be able to identify the y-intercept from words. Okay, we again, I mentioned it yesterday, but it wasn't something that we really focused on. So we're really going to focus on y-intercept today in equations and words. So let's take a look at this first little intro. It says the equation of a non-vertical line can be written in the form y equals mx plus b. Okay, that should remind you of our y equals mx, which was a proportional relationship. Proportional. Don't know if I spelled that right. Hopefully I did. But now we're adding this plus b onto the end, and we're going to really focus on what that plus b means. Where the m is the slope, that is a reminder, we should know that, and b is the y-intercept. I mentioned that yesterday, so now it's part of our main idea. So I want you guys to memorize this form. If you need to, put a circle around it, point arrows at it in your notes. This is the most important idea here, that m is the slope and b is the y-intercept. And we're going to use those ideas to be able to graph and write equations ourselves. So it says an equation written in the form y equals mx plus b is in slope-intercept form. It is very important that you understand what the form is called, because when you get to Park is going to ask you to put things in slope-intercept form, and they're asking for y equals mx plus b. You can use the slope-intercept form to write and graph equations of a non-vertical line. So let's take a look at our first example. It says write an equation in slope-intercept form. So if we memorize it correctly, you see the word slope-intercept form, you should think y equals mx plus b. Okay, where m is the slope and b is the y-intercept. So first, before we create the equation, let's just identify what is m and what is b on each of these graphs. So I think the easiest thing to identify first is the y-intercept, which I can tell the blue line crosses the y-axis at 1. Now I want to be able to find the rise and the run. So I'm going to zoom in on this graph and just locate first two integer value points. I'm going to highlight them here. I can use the y-intercept at 1. That would work. And the next integer value point I see is this one right up here. So I want to count now the rise and the run from point to point. So my rise right there, my run right there. My rise is going to be, oh, let me change the colors there. 1, 2, 3 units. My run, only 1 unit. So my rise over run is going to be 3 over 1, or just 3. So when I write my equation, I just now need to plug in what I solved for m and for b. So the things that never change are going to be the y equals the x, and you fill in the rest. Okay, so you want to fill in the slope and you want to fill in the y-intercept. Now, the y-intercept should always be plus if it's positive. If it's negative, that is minus. So in my example, I have my slope is 3 and my y-intercept is positive 1, so I should put plus 1. So my equation here is y equals 3x plus 1. Let's take a look at the next example. again, let's identify our m and our b first. In fact, I am going to zoom in and identify the y-intercept first, which is right there. That's where it crosses the y-axis. That is at 4. And I'm going to locate another integer value point. The next one I see is right here. And I can figure out my rise and my run. So from the leftmost point, I have to fall and run. I had to fall 2, and I had to run 1. So my slope is going to be, and actually, sorry, I should put negative because that was a fall of 2. That is -2 over 1, or just -2. So when I create my equation, again, it has to be in y equals mx plus b. And again, the y never changes, the equal sign never changes, the x never changes. We just need to fill in the slope and the y-intercept. So my slope here was -2, and my y-intercept was +4, so I'm going to put +4, and that's my equation. Let's try this one more time on part C. Again, we're going to identify what the slope and the y-intercept are first, so my m and my b. Again, I see it crosses the y-axis right there. That's at -3. That's my y-intercept. And then I want to locate another integer value point. The next one I see is right there. And again, I want to go from the leftmost point to the rightmost point. So I'm going to start my pen here, and I'm going to count rise and run. So my rise this time was 1, and my run was 2. So my slope is going to be 1 over 2. So again, I need to think of y equals mx plus b. The y never changes, the equal sign never changes, the x never changes. I need to fill in the m and the b. I see m is 1/2 and b is -3, so I want to put -3. And I've just created 3 equations that represent these graphs. In fact, a synonym for these equations would be function rules. Function rules. Something we kind of forgot when we took our last exam. Rules just mean equations. Okay, these are function rules. All y equals mx plus b's are going to be functions. So these are their function rules. Let's have you guys try the same thing on your U-Try. All right, so let's take a look at our second example. We have a real-life situation here. It says the line models the relationship between a temperature in degrees Celsius and degrees Fahrenheit. We can actually see that on our graph. I see temperature in Fahrenheit on the y-axis. I see temperature in Celsius on the x-axis. So I'm actually going to label those things. It says a line models the relationship between Celsius, which is x, and degrees Fahrenheit, which is y. That's just a little reminder for me. What is the y-intercept of the line? What is the slope of the line? So let's answer those 2 questions real quick before we move on to the next question. The y-intercept I can see right here. That's where we intersect the y-axis. Now be careful because you can't really tell where that point is. That's why they tell you what the coordinate is. So this point is at 0, 32. And remember, whenever x is 0, then the value that is the y is the y-intercept. So the y-intercept here is 32. Write that down. Y-int is equal to 32. Slope of the line, we need to count our rise and run. But I say count, and we actually can't count this because if I were to make a slope triangle, I can show you my rise and I can show you my run, but I don't necessarily know how to count what's in here, like to be able to trace it with my finger. Same thing here, because the points are not on integer, well, they're not on cross sections of the grid. They are lying on integers, but it's just the way that this graph is scaled that makes it impossible for us to be able to count the grid lines to be able to see what the rise and run is. So remember, we do have a slope formula. M is equal to y2 minus y1 over x2 minus x1. So I'm going to take these points that I see and I'm going to label them. I have 0, 32, and I have 40, 104. So this is my first point, this is my second point. I'm going to label x1, y1, x2, and y2. So when I plug into my formula, I have 104 minus 32 over 40 minus 0, which 104 minus 32 is equal to 72, and then 40 minus 0 is 40. We need to reduce that fraction down. So remember, whenever you're reducing, try to divide each number by something they're both divisible by. These are two even numbers, so I'm going to start with dividing them both by 2. I'm going to get 72 divided by 2, that's 36. And 40 divided by 2 is 20. I can tell they're still even numbers, so I can divide them by 2 again. What I'm doing right now is just making sure they're reduced down. Okay, so I'm getting 18 over 10. I can reduce that one more time, or maybe 2, I don't know, let's see. 18 divided by 2 is 9. 10 divided by 2 is 5. There we go. That's as reduced down as it's going to get. So my slope is 9 over 5. Okay, so I've identified now my y-intercept and my slope. The next part says, write an equation for the line where x is temperature in degrees Celsius and y is temperature in degrees Fahrenheit. So an equation, again, the form we know is y equals mx plus b. Y doesn't change, the equal sign doesn't change, the x doesn't change. We just need to plug in the slope and the y-intercept. Remember, m is slope, so our slope here was 9/5. Our y-intercept is that b. We said the y-intercept was positive 32, so we need to do plus 32. There's our equation. Seems like we have more to do because it does say move on to the next screen, so let's see what else they're going to ask us. It says the line is the graph of the equation y equals 9/5 x plus 32. Hey, that's the equation that we just created, where x is the temperature in Celsius and y is the temperature in Fahrenheit. Find the Fahrenheit equivalent for 18 degrees Celsius. Okay, now I can't see 18 on this grid because they're not counting by ones. So 18 is going to be like about right there, and if we look up to the line, I can't really tell where that point is because it's not on an integer value. We could guess maybe 73, 74, but we're not going to guess. We need to be accurate. So let's take our equation, y equals 9/5 x plus 32, and we're going to plug in 18 degrees Celsius into the variable that stands for Celsius, which would be x. The x-axis has Celsius on it. So I'm going to plug in 18 in for the x value in my equation to figure out what the Fahrenheit value is, which is y. So y equals 9/5 times 18 plus 32. So I'm going to do 9/5 in my calculator times 18. That gives me 32.4. We still have to add 32 to it. 32.4 plus 32 is going to be 64.4 degrees Fahrenheit. So when it's 18 degrees Celsius, it's 64.4 degrees Fahrenheit. Let's have you guys give this a try. in your U-try. All right, so we've got one last thing to go over, one last idea and example. This little intro to the last example says you can use an equation in slope-intercept form to graph a linear equation. The y-intercept gives you the starting point. I am going to highlight that, and I want you guys to highlight that as well in your notes. The y-intercept, oh, don't cross it out. Get a highlighter or circle it or something. The y-intercept gives you a starting point. You should always start with the y-intercept. You will be tempted to start with the slope, okay? Because slope is the first number that you see. So, like here, the first number you see, oh my gosh, why won't my pen become smaller? Okay, there we go. All right, so the number I see here is 4/3. That's the first thing that your eyes see as you're reading the equation, but that is the slope. So please do not start there. Start at the y-intercept, okay? Start at the y-intercept. So first, let's plot -1 on the y-axis. Okay, so here is -1. Whoop, a little too big. Let's get a different pen. There we go. There's -1. And now that we have an initial point, we can start using the slope. Okay, now our slope here is 4/3. So that means from the y-intercept, we need to rise 4. I'm going to write this down. Okay, what this means is we need to rise 4, run 3. So start your pencil on -1. Then from -1, rise up 4 units. So from -1, if we go up 4 units, that brings us to 3. Now we need to run 3 units. 1, 2, 3. So now we plot the point. We've started from the y-intercept, we've done our rise and run, and we can plot the next point. Now connect the dots, and that's all we have to do to create this line. Before, we would create tables to do this, and this is kind of like a quick trick now that we've learned what all these different pieces of this formula really mean. So there's no need to make a table anymore. All we need to do is look at the b and the m, starting with the y-intercept and then applying the slope. So let's try this in another example. It says graph the equation y equals 1/4 x minus 5. So first I'm going to pick out in this equation what the m and the b are. The m is the 1/4, the b is -5. Please make sure you take that negative with you. Okay, this negative is part of the 5, so b is -5. Please don't write just down 5. So now we have to go to our graph, and again, we start with the y-intercept. Start with the y-intercept, which is -5. So I'm going to plot -5 on the y-axis. Next thing we have to do is actually do the rise and the run from -5. So I'm going to start my pencil at -5, and I'm going to count up 1 unit. Okay, so that would bring us to -4. Here, let me zoom in a little bit. Okay, brings us to -4. And then we need to run, sorry, I already forgot, 1/4. So we need to run 4. So 1, 2, 3, 4. That's where we're going to make our next point. There we go. And then now that we have 2 points, that's all we need to make a line. We just connect the dots, making sure we extend the line all the way across the graph, and we put arrowheads on the end. So just from looking at that equation, we didn't need to generate a table or anything now. We can get the graph going without coming up with values, just by using the y-intercept and the slope. Let's have you guys try this in your own U-Try. So just to wrap up what we talked about today, again, our learning target for this week is to compare rates of change and initial values and interpret their meanings. We've actually done some interpretation yesterday as well as today. And we've also done a little bit of initial value, talking about how y-intercept is where we start. So again, our success criteria was to identify the y-intercept from an equation. We did that in example 1 and example 2. We also identified the y-intercept from words. In words, we talked about where things start. Okay, that was also in example 2. If you have any questions, please let me know. You may go ahead and start your practice.